Hello everyone, hope you all fine. Today I Lakshmi Negi again with you with the new chapter, chapter number 9th. The name of new chapter is Area of Parallelogram and Triangles. First we will understand about that what are the figures having same base. You can see in these all figures there are the two figures which are having the same base. In first there are two parallelograms having same base, and in second also there are two parallelogram having same base. In third there are two triangles having same base, and in the last one there are the two figures, one triangle and one parallelogram having same base. Now in this figure, these all figure, you can see that there are all the figures which are having same base but lying between the same parallel lines. You can see that there are the two figures, two parallelogram PQRS and MNRS. Both the parallelograms lies between the same base and between same parallel lines. On the basis of the above, you have to give the answers of the questions of this exercise. Now you can see that I am going to read the first question. Which of the following figures having the lie on the same base and between the same parallel lines? In such case, write the common base and the two parallel lines. So you can see that the figure first, third, and this the fifth one, these figures lie between the same parallel lines and having same base. The same base and lying between the same parallel lines. Now moving to the next exercise and the basics of the next exercise. This is a very important theorem. The theorem states that the parallelogram on the same base and between the same parallel lines are equal in area. I just want to explain you that there are the two parallelograms. You can see that A, B, C, D, one parallelogram, and the another one is E, F, C, D. These are the two parallelograms, and these two parallelograms lie between the same parallel lines. You can see that these both are lying between the same parallel line DE. I can make a figure for you also that this is one parallelogram and this is the another parallelogram. You can see that both the parallelograms, that's mean that you can give a name ABCD, or I can take the another one color ABCD and the another one is PQCD. So these two parallelograms, you can see that both are having the same base. This base is same. So both the parallelograms having same area we have to prove in this question. So see how we will do this question. So this theorem. Now see in this theorem, first what we have to do, we have to make two triangles congruent, this one and this one. We have to make these two triangles congruent since we know that both are parallelogram. Now you can see that we will take two triangles. The triangle, since we can see that both the parallelogram ABCD and EFCD on the same base DC and same between the same parallel lines, and we have to prove that the area of ABCD is equal to area of EFCD. Now we will take two triangles. As I told you that we will make both the triangles congruent. ADE, this is the ADE triangle, and BCF is this is the triangle. Now we have to take three things to make both the triangles congruent. So you can see that what three things we will take together. The first one is corresponding angles. Since we know that this is parallel to this, so we can see that this one angle and this one angle, you can see that these two angles will be equal to each other because these are corresponding angles. Similarly, if you will see that AED, that's mean this one angle, I can take the another color pencil also, this one and this one angle, these two angles are also equal to each other because these are also corresponding angles. Now the third, you should understand that if the two angles in any two triangles are equal, therefore the third angle will definitely equal to each other. Therefore, these two angles will be equal to each other. Now, the opposite sides will be equal. This side equal to this side because these are the opposite sides of parallelogram. And this side equal to this side. These are also opposite sides of parallelogram. So, we can say that from SAS congruency, from SAS congruency, both the triangles will be congruent to each other. This triangle and this triangle, from SAS congruency, both the triangles will be congruent to each other. Now adding the area DEBC both the side. If the area of these two triangles will be equal to each other, and we will add these two area both the side, you can easily see that if we will add this area to the first triangle, we can see that we will get the area of ABCD. Similarly, if we will add this area to the another triangle BFC, we will get the area of EFCD. Hence, both the area will be equal to each other. This is very important theorem. Now moving to the next example, which is example number 2, which is not only the example, it is actually a theorem that if a triangle and the parallelogram are on the same base and between the same parallel lines, then prove that the area of the triangle is equal to the half of the area of parallelogram. That's mean if you will see that ABCD is a parallelogram and on the same base there is one triangle also, it is PAB, and you have to find out the area of PAB is half of the area of ABCD. So for that, first you will draw a line QB which is parallel to PA. Now you will see that, as I have earlier explained you, the area of two parallelogram having same base and lies between the same parallel line are equal. Therefore, the area of these two parallelogram, that's mean PQBA is equal to DCBA, or you can say that ABCD. ABCD is equal to, you can say that ABQP. Though both the area will be equal to each other. Now you can see that PB is the diagonal of the parallelogram PQABA. So this diagonal bisect the triangle in two equal area. Therefore, PAB is equal to PQB. You can see here, we have written here PAB is equal to PQB. Since we know that PAB is equal to half of area of APA, because this PAB is the half of the parallelogram ABQP, and we know that area of ABQP is equal to ABCD. Hence, we can say that area of the triangle is half of the area of parallelogram, and that is also a very important theorem. Now moving to the first question of the exercise 9.2, in which you have given the three dimensions 1, 2 and 3. You can see that you have given that in this figure you have given the value of AB and you have given the value of corresponding height A, and you have given the value of CF which is corresponding height of AD, and you have to find out the value of AD. Since you know that the area of parallelogram is base into height, when you will take base as AB, then height will be AE. As you can say that AB into AE, that's mean the area will be 128 centimeter square. Now, if you will take the base as AD and the corresponding heights will be CF, in that case the area of ABCD is equal to AD into CF. Since we know the value of only CF, so we will substitute the value of FC which is 10, and AD we don't know, we will put it like that. Now since we know that in both of the cases the area of ABCD will be equal, we will make both the areas equal, and hence we will find out the value of AD which is equal to 12.8. Thank you very much.